Good morning, learners and viewers. Welcome to the session for operations. Good morning, learners and viewers. Welcome to the session of Operations Management MMPO 003. In my previous session, we discussed about Unit 2. Now, moving further, today we will be talking about Unit 3 and the subsequent units. Unit 3 is sustainable operations. The transformation of sustainable business strategy into sustainable operations takes place through an integrated quality, environmental, and safety management system. Key elements of this methods are performance measurement and ongoing improvement, which is continuous in nature. Sustainable operations include elements such as total quality control, sustainability, environmental stewardship, and process safety. In order to remain competitive, operations and production management must effectively alter their supply chain strategies in response to changing market situations. Due to numerous changes in business and society over the last 20 years, research on sustainable operations management gained momentum. Industries and governments throughout the 1990s concentrated on resource productivity and the need to use resources more wisely and consume less of them. The focus on environmental friendly goods and procedures and the reduction of waste and carbon dioxide emissions and recycling have all generated interest in environmental performance. These factors encourage companies, service providers, and governments to pursue sustainable operations using the following strategies. And these are presented in this unit, and they are namely triple bottom line, what we call as TBL, reverse logistics, circular economy, and decarbonization. We'll start with triple bottom line, that is TBL. The concept of triple bottom line reporting has been more popular over the past few years in management, consulting, investing, and business circles. According to TPL paradigm, a company's overall performance should be assessed in terms of its social, ethical, and environmental performance, in addition to its traditional financial bottom line, which is profit maximization. TBL is a structure. It considers the social, economic, and environmental facets of performance. This deviates from customary reporting frameworks since it includes ecological, or what we can say as environmental and social indicators for which it may be difficult to determine the appropriate measurement techniques. The common phrase is three P's, which stands for people, which is related to social, planet, that is environmental, and profits, which is related to finance. Sustainability depends on the TBL idea. Here we can see that economic, environment, and society both are interrelated or intermingled within themselves. And this is the nested sphere model of triple bottom line. The concept of TBL has been adopted over times as a guiding principle for many important organizations, corporate strategy, and operations. The principle behind TBL is that it requires organizations to be accountable to all its stakeholders, including those who are directly impacted by the actions of the other party or stakeholders in the company, as well as to the organization itself. People, that is the social dimension of it. The TBL's people component is the first and focuses on how organizations should treat their workers and the communities they have an impact on them in just and beneficial ways. Second one is environmental, that is planet dimension. This is the second level of TBL. Sustainable environmental actions are referred to as a planet. A TBL company works to preserve the environment and avoids doing anything that can upset the delicate ecological balance. By strictly regulating the use of non-renewable resources and energy, the corporation lessens its influence in the environment. It implements methods for assessing the cost and effects of its products and services on the environment. The third one is profit economic damage. This is the third and the final dimension of TBL. Profit, which is determined after deducting all input costs, including the cost of capital invested, serves as a representation of the organization's economic value. Adopting a triple bottom line strategy may appear unrealistic to some in a society that prioritize profit potential, but innovative businesses have repeatedly demonstrated that it is possible to make money while doing good. The triple bottom line does not, by definition, prioritize societal, and environmental effects over financial success. Instead, adopting sustainable business practices has paid off for many companies financially. Then comes your reverse logistics. In an integrated approach to logistics management, a closed loop supply chain integrates forward and backward logistics. Closed loop supply chain, what we call them as CLSC. This deals with both forward and reverse supply chains with a focus on reclaiming extra value by reusing the complete product and for some of its sub-assemblies, components, and parts after being returned to customers. A system's design, management, and operations are described as maximizing value generation throughout a product whole life cycle with dynamic value recovery from various types and volumes of return over time. Here we see that what is the actual framework of closed loop supply chain system. If we start with the suppliers, we go on to manufacturers, then comes the wholesalers, retailers, first customers. When the customer uses it, it is sent for repair or to the service center. If the depending upon the nature of the problem, it, next step is collectors. Then, if everything stops working, then it is refurbished again to the reseller, and then comes the second customer. With the blue line arrows, we see that that is forward flow from supplier to first customer. The red arrows, which are dotted one, represents product returns. Here it is visible on the right side of the screen. The first two customer either send it back to the retailer or it is sent for the repair. The green one, the dotted green one, shows the reverse process. That means it will be going back to the supplier. And the dark green arrow is the actual reverse flow. This is how we can see that the things are related in closed loop supply chain system. Then we will see what is meant by forward logistics, the movement and storage of raw material, work in process inventory, and finished commodities from the point of origin to the site of consumption are all part of managing the flow of goods and services as depicted in the figure. Raw material, suppliers, manufacturers, distribution, customers, consumers. This is forward logistics. Forward logistics is a discipline that deals with the connivance of goods via temporary partners such as wholesalers or the retailers from manufacturing centers to the customer or warehouses. Second part is reverse logistics. According to the Reverse Logistics Association, RLA, the ultimate goal of reverse logistics is to optimize transportation activities after marketability, saving money and environmental resources. The framework of the reverse logistics is like this. Here we see how does this reverse logistics work. Raw material, that means now the movement is from the consumer to this non-used product packaging and waste that comes way back to the distribution, manufacturer, raw material. If it can move from the consumers to the test and assembly, these all branches are intermingled and related among themselves. This is basically the complete reverse logistics cycle. Now, what are the types of product returns in closed loop supply chain? The initial purpose of a product by a customer does not mark the end of the company's supply chain operations. A business must take into account the products that customers return or discard, both business and domestic. The number of factors, including manufacturer's return, product recalls, warranty returns, service returns, commercial returns, end of use returns, and end of the life returns may contribute to the reverse flow of items. This section presents the three primary product return types that are essentially taken into account in the closed loop supply chain. First one we will start with commercial or consumer return. Product have been returned commercially or by the consumer can be done so for a number of different reasons, some of which are product manufactured having defects, product still covered by warranties, products that does not match the order of the purchase, unsold goods under no question asked, written policies at retailer's point of sale. Now these are the conditions under which the product comes back. End of use return. Under this, the goods that customers send back after using them for a considerable amount of time, or if they become outdated due to new technology advancement. In many cases, even perfectly functional products are returned by the customers who prefer to replace them with more recent or improved models or versions. The best example includes cell phones, other consumer goods, and fashion accessories. Cell phones and laptops are the most things which are updated or written back by the user in working conditions. End of life returns. Products that have been returned by the customers after reaching the end of their useful or planned lifespan are known as end of life returns. The right amount of energy, money, and allocation to secondary market items are needed for the proper disposal, recycling, or recovery of these products pieces. Example includes costly, outdated, long-lasting electronic equipment, cars, and other commercial goods that are non-functional, extremely expensive to fix, and not in reusable form. Reverse process for product returns. The three models covered in the previous section are used to process client returns of merchandise, redistribution, disposal, landfilling, incineration, recycling, refurbishment, remanufacturing, repair, reuse, cannibalization, and resale are some of the options for reprocessing and disposition of product returns. The following is a discussion on these processes. First one, we will start with redistribution. Redistribution is the process of physically transferring reusable goods to potential customers and markets. Activity includes sales, shipping, and storage may be included. Second one is disposal. Product that cannot be reused due to technical or financial constraints must be disposed of. This is true for both products with unsatisfactory market potential due to obsolescence and products that were rejected at the separation stage due to significant maintenance requirements. Transportation, landfilling, and incineration processes are all possible disposal methods. Landfill. The non-recoverable goods or components which are regarded as wastes are dumped in landfills. For some products, this choice is prohibited in specific jurisdictions. For instance, the majority of states in the US prohibit the disposal of hazardous wastes in landfills. Incineration, amount of solid waste dumped in landfills is decreased in part due to insulation. For instance, insulation, which is the process of burning solid waste, can cut the amount of solid waste up to 95%. Energy recovery or the extraction of energy from waste is another common application of insulating garbage. Then comes your recycling. Recovery of materials is implied by this choice. This disposal choice is appealing for returns that have little or no functional use left and whose materials can be economically and environmentally separated. Very old electronic equipment that have reached the end of its useful life is regularly recycled. For further material separation, such as plastic, steel, aluminum, and precious metals, and recycling of each material type, the product is shredded in this situation. Recycling might be the most environmentally friendly option for end of use returns like outdated appliances. This is due to the fact that producing equal new components and sub-assemblies require more energy. Remanufacturing, rebuilding and restoring a piece of equipment or a musical instrument to its original performance status is known as OEM performance tuning. Remanufacturing, according to Hosier and Flint, 2003, is a lengthy process that includes disassembly, cleaning, repairing and replacing parts, and reassembly in order to return worn products to like new state. Refurbishing. It is the process of maintaining and or renovating older or damaged equipment to restore it to a functional or more appealing state. You might be aware of there are many companies which are selling refurbished laptops, computers again to the open market and that to a low cost. Reuse is nothing more than the act of reintroducing a good byproduct or waste material as an input into a production process, typically without undergoing any physical or chemical modification. Repair. It involves putting a malfunctioning, broken, or damaged piece of equipment back together again so as that it can be used or operated. It is also refers to a procedure applied to a non-conforming product to enable it to perform the intended function. Then comes your carbonization, the detrimental effect of a company's new product on the sales performance of its existing related items is known as cannibalization. It describes a situation when products are returned because a new product has largely replaced the sales and demand of the older one. Instead of increasing the company's customer base, cannibalization happens when a new product invades the market for the older product. Then comes your resale. In the event that there is a vibrant secondary market for used equipment, this choice can be appealing. For instance, IBM sells part of its used IT equipment that it recovers from end of lease to licensed brokers who may refurbish to resell it. Then comes your sustainable supply chain. A supply chain that fully incorporates moral behavior and consideration for the environment into a competitive and fruitful model is said to be sustainable. Transparency throughout the whole supply chain is essential. Sustainability measures must cover everything from sourcing raw material to the last mile logistics to provide returns and recycling processes. 20 years ago, the term sustainability and eco-friendliness work virtually interchangeably. Now, a much more inclusive term. A modern sustainable supply chain includes elements like green, transparent, and circular supply networks. Circular economy. By reducing environmental impact and resource waste and boosting productivity at all phases of the product economy, the circular economy seeks to shift the paradigm in respect to the linear economy. The creation of a circular economy is being aided by recent warnings about trash pollution and the depletion of natural resources. The circular economy is a framework of the system level solutions that address issues including pollution, waste, biodiversity loss, and climate change. What is the principle of circular economy? Circular economy is based on three principles which are driven by design: eliminate waste and pollution, circulate products and materials. The third one is regenerate nature. If we talk in terms for eliminate waste and pollution, the elimination of waste and pollution is the primary tenet of the circular economy. We use the earth's resources as raw materials to create products. Then we discard the finished products as waste. Most of this garbage is lost when it is disposed of in landfills or incinerators. Because the resources on our planet are limited, this system cannot function over the long run. This respect of design will move from linear economy to circular economy. The linear economy follows take, make, use, and waste, which means that the components and assemblies of the product will be wasted after the end of life of the product. The product that is designed using the circular economy will not have waste and pollution. Circulate products and materials. Circulating goods and materials at their peak value in the circular economy's second tenet. Maintaining materials in use implies using them either as a product or when there is no longer possible as component or raw materials. Nothing is wasted in this manner, and materials and goods maintain their inherent value. There are numerous ways to maintain the circulation of goods and resources, and it can be useful to consider two primary cycles, that is, the technological cycle and the second one is biological cycle. Products go through the technological cycle, which includes reuse, repair, remanufacturing, and recycling. Through procedures like composting and anaerobic digestion, biodegradable materials, etc., are recycled back into the environment as a part of biological cycle. Technical cycle is maintaining and reusing things is the best approach to maintain their worth. Consider a phone as an example. As a phone, it is significantly more valuable than as a collection of parts and materials. Therefore, the every step in the technical cycle are concentrated on maintaining items in their whole or retain the most value feasible. This could include sharing based economical models that allows user to assess a product rather than own it, allowing more people to use it over time. It can entail recycling through resale. It could mean cycles of maintenance, repair, and refurbishment. At the end of the life of a product, its components can be remanufactured, or it is, if it is not possible to remanufacture the components, they may be divided into their consistent materials, which may be recycled. And this will help us to avoid waste. Biological cycle. In the biological cycle, biodegradable materials that cannot be recycled, such as some food leftovers, can be recycled back into the economy. Important minerals like nitrogen, phosphorus, potassium, and micronutrients can be used to regenerate the soil so that we can grow more food, or renewable materials like cotton and wood by composting or aerobically digesting organic waste. Regenerate nature. Regeneration of nature is the circular economy third tenet. A circular economy, as opposed to a take make waste linear economy, supports natural processes and creates more space for nature to flourish. Regeneration follows extension. We create natural capital rather than perpetually destroying nature. We use farming techniques that let nature regenerate soil, boost diversity, and replenish the soil with biological resources. Framework of circular economy. You will see here. This is basically a diagrammatic view of a circular economy. There are different, we can say there are two layers of it. First one is the energy and the second one is, and the last one is the end process of it. At the top, we have different production and distribution units, consumption and stock, then eco-design, materials, wastes, recycling, emission. At every stage, we have to think of how sustainable the economy can be maintained. The components of this framework, commencing from production and distribution. First one is extraction and import of natural resources, including energy carriers. Second one is the material, which includes biological material and the technical material. Third one is eco-design, energy, production and distribution. Sixth one is consumption and stock. Seventh one is waste and emission, incineration, landfill. The last one is the recycling. Extraction and import of natural resources, including energy crisis, carriers. The manufacture of goods begins with the extraction of material resources, including energy carriers. One should take enough care to locate even the point of extraction of materials resources if there are alternative production centers in relation to the end customers such that the following measures of performance are minimized. Second one is the materials. Materials are classified into biological materials and technical materials. Innovation in sustainable biomanufacturing are being made possible by advances in cell-free synthetic biology. And these advancements have the potential to change the global manufacturing paradigm in favor of more regionalized and ecologically sound production methods. Common materials used to produce manufactured goods include technical materials. Example of materials include glass, steel, and other metals, plastic, porcelain, and ceramics, planks, and concrete. Eco-design. The exercise of the design of product should take enough care to ensure the durability, reusability, and ease of repairing the products should be maximized. Maximizing the presence of substances that inhibit circularity. Maximizing the energy efficiency and resource efficiency. Maximizing renewable content components of products. maximizing the remanufacturing and recycling features of the product and minimizing the impact of carbon and environmental footprint. Then comes energy. The operations of the manufacturing service facilities require energy. There are several sources. The energy sources are classified into renewable sources and non-renewable sources. If we talk about renewable sources of energy, it includes solar energy, wind energy, hydropower, tidal energy, and bioenergy. Whereas non-renewable sources include thermal power, nuclear power, and fuel-based power such as aeronautics. Since the supply of power is the responsibility of the government, either through its own initiatives or through authorized private players, the government should take steps to maximize power generation and reduce pollution and losses. Then the fifth one is production and distribution. Production distribution forms the most crucial stage of the circular economy. Production, manufacturing combines the resources to produce an intended product subject to different constraints imposed on resources. This operation should be such that each unit cost of manufacturing of the product is minimized and to have a competitive edge in the market. At the same time, the companies should take enough care to choose the facilities of manufacturing such that the negative impact on the environment, like pollution, carbon emission, etc., are minimized. Then comes consumption and stock. The products that are shipped to the end customers are consumed by them, and a portion of the supply will be kept as stock to smoothen their operations in the case of industrial customers. Then comes your waste and emission. The products which reach their end of life by end customers will become a waste as well as a source of emission in the case of electronic waste. Insulation and landfill are the two options to handle the waste. Insulation is the process of burning waste with proper control to minimize the emission of carbon. The landfill is the process of burying the waste of end-of-life products such that they do not pollute groundwater. Recycling. The products designed with the objective of circular economy should have the features like reuse, repair, redistribution, refurbishment, and remanufacturing. If we talk about reuse, simply said, reuse is the recurrent usage of a goods or components in its initial configuration. Utilizing a glass milk container along the producer-customer chain, for instance, several times instead of using a plastic bottle. Redistribution, reusing something, also refers to transferring materials and goods from someone who no longer requires them to someone who still utilizes them. Reusing products has advantage for both disadvantage individual and organizations and for the conservation of precious natural resources. The repair component, the life of the products can be increased through a proper repair policy. The system should install repair centers to attend to minor and major faults of the products so that the lives of those products are extended. This leads to minimization of waste. The landfill is the process of burying the waste of end-of-life products such that they do not pollute groundwater. As far as recycling is concerned, the products designed with the the objective of circular economy should have the features reuse, repair, redistribution, refurbishment, and remanufacturing. Then comes your consumption and stock. The products that are shipped to the end users are consumed by them, and a portion of supply chain will be kept as stock to smoothen their operations in the case of industrial customers. Waste and emission, the products which reach their end of life at the end customers will become a waste, as well as the source of emission in case of electronic goods. Insulation is the process of burning wastes with proper control to minimize the emission of carbon. Refurbish is the process of upgrading the quality of products to a desirable level so that the people use them. Remanufacturing is an industrial procedure that allows for the rebuild and recovery of previously sold, used, or non-functional objects. The item can be restored to like new or better than new state through disassembly, cleaning, repair, and replacement of worn out and outdated components, and will be just as dependable as the original product. The key component of the idea of a circular economy is remanufacturing. India's initiative towards circular economy. It is clear that the nation is moving swiftly in the direction of a circular economy to counteract the drawbacks of rapid urbanization, industrialization, population growth, pollution, and climate change. According to Circular Economy in India, Rethinking Growth for Long-Term Prosperity, a paper by Ellen MacArthur Foundation, if India follows this course, it could result in yearly benefit of 624 billions by 2050 and a 44% reduction in greenhouse emission. There has been a movement for policy in India to hasten the transition to a regenerative model. Smart City Mission aims to change India's metropolitan areas by promoting economic development and raising the standard of living for its people. This effort strives for circularity by making waste management a crucial success factor. Some cities have already made significant advancements in this area. The Indian government is also developing extensive transition plans for a circular economy with a primary focus on 11 areas, which includes municipal solid waste and liquid waste, toxic and hazardous industrial waste, and end-of-life vehicles. By working with the European Union to create an India European Union Circular Efficiency and Circular Economic Partnership, India is also creating international alliance to promote the circular economy. Decarbonization of operations. The various systems that are in operation to meet human requirements, which use oil, grease, and many other fossil fuels, produce carbon emission. This contaminates the atmosphere, posing a hazard to all earthly lives. Decarbonizing the various systems such as thermal power plants, fertilizer companies, steel companies, chemical industries, etc., is therefore necessary. What is the importance of decarbonization? For many businesses, the ideal situation is to have net zero carbon emission, which is a situation in which the greenhouse gases produced by all of their value chain operations have no discernible effect on the planet. Buildings, offices, factories, and warehouses that serve as productivity hubs are at the top of many business decarbonization priority lists. Building accounts for about 40% of planet's overall energy consumption and 36% of its greenhouse gas emission over the course of their lifetime. There is a lot of proof that customers are willing to spend extra on a brand or items that share their beliefs. The road to net zero is anything which decarbonizes the operations of the business, service organizations, and business, etc. That is not that easy to achieve. To begin with, there is no one method that works on all real estate portfolios for eliminating carbon dioxide emissions. The size, ambition, and industry of a corporation all influence its decarbonization objectives. Climate change. Over 81% of the world's primary energy source is still coal, oil, and natural gas as on 2019, which leads to carbon emissions both upstream during the process of energy production and extraction and downstream during the final consumer of the energy. What is the current state of decarbonization of operations in buildings? According to a survey on thought leadership conducted by Johnson Controls and Foresters Consulting, many businesses have trouble in defining their objectives or and unsure of how to get there. The businesses most likely to reach net zero objectives and experience growth recognize that sustainability is not only a responsibility but also the way business will develop in the future. They will just have a competitive advantage according to the study. And the third one is through the opportunities for green business vary from company to company. Great leadership and good partners are the two traits of the most prosperous and sustainably engaged businesses. Companies must set clear objectives, that is, make sure long term investments and pursue solid partnerships if they wish to significantly increase energy efficiency and reduce the carbon emissions of their facilities. Decarbonization pathway. The decarbonization pathway consists of four basic stages. The first one is define success. Second one is set targets. Third one is deploy programs. And the fourth one is sustain results. We'll start with stage one, that is define success. This stage aims to understand the baseline of the operations based on past performance and practice in controlling carbon emissions. This will spell out the success stories of the effort taken by organizations to control carbon emission. The control of carbon emission is a never-ending process, and hence the following stages are present. Stage 2 is set targets. This state sets, validates, announces, and reports on public targets. Setting targets involves defining goals and establishing a live timeline to achieve them. An example may be set as a target that involves reducing carbon emission by 35% by 2030. The smart factory may aim to have the following initiatives: sustainability, trust and resilient, intelligent, and the fourth one is velocity. While setting targets, companies consider scope 1, which is emissions, scope 2 emission, and scope 3 emissions. Among them, scope 3 Emissions are the most difficult to track and improve. Scope 1 emission is these emissions involve everything a company directly controls, such as operations. Scope 2 is the indirect emissions that are result of energy that is consumed by operations. And the third one is the emissions that comes from a company's value chain. The example of Scope 3 generating activities include the way goods are transported, corporate travels of employees, peripheral organizational activities, and waste disposal. Stage 3 is deploy programs. This stage includes the following initiatives. First one is manage energy supply. Second one, optimize resources and carbon intensity. Third one is switch from carbon intense to low carbon energy sources. Fourth one is balance emissions, which cannot be reduced. And the fifth one is engage value chain and address scope emissions. Stage 4 contains it shows sustained results. This stage includes the following initiatives. The first one is measure, monitor, adjust, and optimize. The carbon emission should be measured and compared with a threshold value. If it exceeds strict and integrated action should be taken to adjust and optimize the carbon emission. Second one is communicate progress. The progress made in carbon emission should be communicated to the stakeholders, government, and public, which will motivate others to join hands in this endeavor. Now we will see a case study of decarbonization efforts in agriculture. Every year during the harvest season of its neighboring states, Delhi, the capital city of India is experiencing carbon pollution. This is a result of burning straw as soon as it is harvested, which emits smoke and carbon dioxide over a large area surrounding the states that engage in this activity. The farmers primarily utilizes this technique to recycle the straw as manure for their fields, but they overlook the carbon emission that results from it. This results in the temporary closure of elementary schools until the air quality is safe for children to breathe. This is the step which was taken, which is normally taken by the government. What is the solution towards net zero carbon emission? The steps suggested to have net zero carbon emission due to the burning of straw are given below. Number one, cut the straw into pieces. Spread the pieces of straw in agri field. Fill the agri field with water. After a few days, plow the field for 2 or 3 times. Allow the field to form composite from wet straw. Again, plow the field for a necessary number of runs through the plantation of paddy. This approach completely avoids the burning of straw immediately after harvesting, which leads to net zero carbon emission. Now, we move to block 2, which is related to designing operations. It starts from unit 4, that is process and capacity analysis. So initially, we will start with capacity planning. Capacity planning is a key strategic component in designing the system. It encompasses many basic decisions with long-term consequences for the organization. What is capacity? This refers to the upper limit or ceiling on the load that an operating unit can handle. The load might be in terms of number of physical units produced, that is, examples, bicycles assembled per hour, or the number of services performed, that is, computer upgrading per hour. The operating unit might be a plant, a department, a a machine, a stove, or work. A gap between current and desired capacity will result in capacity that is out of balance. Overcapacity causes operating costs that are too high, while undercapacity causes strained resources and possible loss of customers. The key question in capacity planning are the following. What kind of capacity is needed? How much is needed to match demand? And the third one is when it is needed. The question of what kind of capacity is needed depends on the products and services that management intends to produce or provide. In a very real sense, capacity planning is governed by those choices. Before an organization commits to ramping up its input, it is essential to confirm that its supply chain will be able to handle related requirements. Because of the uncertainties, some organizations prefer to delay capacity investment until demand materializes. The initial step for the capacity development is the process selection. Process selection refers to deciding on the way production of goods or services will be organized. It has major implications for capacity planning, layout of facilities, equipments, and design of work system. Process selection occurs as a matter of source course when new products or services are being planned. However, it also occurs periodically due to technological changes in products or equipments as well as competitive pressures. This is a diagram which depicts the process selection and capacity planning influence system design. Input can be in the form of forecasting, product and service design, and technological change. This all will be processed which defines capacity planning and process selection. And your output will be in the form of facilities and equipments, layout, work design, forecast, product and service design, and technological considerations all influence capacity planning and process selection. Moreover, capacity and process selection are interrelated and are often done in concert. They in turn affect facility and equipment choices, layout, and work design. How an organization approaches process selection is determined by the organization's process strategy. What are the key aspects which are included into it? It is capacity, intensity, the mix of equipment and labor that will be used by the organization. Second one is process flexibility, the degree to which the system can be adjusted to changes in processing requirements due to such factors as changes in product or service design, changes in volume processed, and changes in technology. What is process type? There are five basic process types in production: job shop, batch, repetitive, continuous, and project. If we talk about job shop, job shop usually operates on a relatively small scale. It is used when a low volume or high variety goods or services will be needed. Processing is intermittent. Work includes small jobs, each with somewhat different processing requirements. High flexibility using general purpose equipments and skilled workers are most important characteristics of a job shop. A manufacturing example of job shop is a tool and die shop that is able to produce one of its kind tools. A service example is a humanitarian office which is able to process a variety of animals, and a variety of injuries and diseases. Second one is batch. Batch processing is used when a moderate volume of goods or services is desired, and it can handle a moderate variety in products or services. The equipment need not to be flexible as in job shop, but processing is still intermediate. The skill level of workers does not need to be as high as in job shop because there is less variety in job processed. Example of batch systems includes bakeries, which make breads, cakes, or cookies in batches. Movie theaters, which shows movies of two groups, batches of people, etc. Third one is repetitive. When higher volumes of more standardized goods or services are needed, repetitive processing is used. The standardized output means only slight flexibility of equipment is needed. Skill of worker is generally low. Example of this type of system includes production lines and assembly lines. Familiar products made by these systems includes automobiles, television sets, pencils, and computers. An example of service system is an automatic car wash. Continuous work. When a very high volume of non-discrete, highly standardized output is desired, a continuous system is used. These systems have almost no variety in output and hence no need for equipment flexibility. Workers' skill requirements can range from low to high depending on the complexity of the system and the expertise workers need. Generally, if equipment is highly specialized, worker skills can be low. An example of non-discrete products made in continuous system includes petroleum products, steel, sugar, flour, and salt. Now here, this is basically a diagram which depicts volume and variety influence process choice. We have high, moderate, low, and very low. That is flexibility. And here in terms of the volume, low or very low volume, moderate volume, high volume, and very high volume. So you can see that when we have a restriction, low or very low volume is required, but flexibility is required is very high. So it will be a nature of job shop. Down the line, when where there is very high volume and very low flexibility is required, it is similar to a continuous flow, which can be in terms of petroleum refining, water treatment, etc. This is basically a figure which depicts type of manufacturing processes. With this, we will be stopping today and we will be continuing further in my next session.